Welcome back, folks. We are going to get into section 6.4, 7.1, 7.2. It's a little bit of a change in topics in this particular sections, but we'll see how they link together though. Okay, so we ended up last time looking at proportions and how we can set those up pretty quickly when they're given to you. But the problem is going to lie in this section about how do we actually set them up from scratch. So if you're given an applied problem, what do you do? Well, okay. Now, one of the nice things about these problems is that they're going to generally involve rates. Now, rates are going to be nice because, remember, they have units in there. So when you're trying to set them up, you're going to use those units to your advantage. And we're going to see how to do that. So if 2 cups of cereal contain 50 grams of carbohydrates, how many grams of carbohydrates are in 5 cups of the same cereal? Now there's lots of ways to set these up correct, but there's also lots of ways to set them up incorrect. So you got to be really careful. Now if you don't use the units, that's where problems can happen. So the nice thing about these, or the one thing that I like to do at least, is to, when they have a comparison of 2 cups to 50 grams or whatever it is, but you know they're linked together, use that as one side of your proportion. So I would say 2 over the 50. Now, if you're not sure about how to set up the other side, here's where you can write the units in. So the 2 cups and the 50 grams. So right off the bat, we know that cups is on top and grams is on the bottom. So when we want to write the other side, we need to have that same relationship, same order. So they say how many grams of carbohydrates are in 5 cups of the same cereal? So again, we got grams and cups. So where do the grams go? Where do the cups go? So we can clearly see that the 5 cups is going to have to go on top. So that way it stays the same. Cups is all on top, and then we don't know the number of grams. So we're going to put an X in for that. And now we have our proportion. So now we can kind of forget about the units for a minute. So once you have a proportion, what do you do next? And I kind of indicated it there, right? We're going to have to cross multiply. So we can take this proportion and we can rewrite it as 2x equals 5 times 50, or 50 times 5. So if we simplify a little bit, we're going to get 2x equals 250. And now we can get rid of the 2 by dividing. So now you don't want to forget your units. So these problems are applied. So you want to make sure you put those units on your answers. Otherwise, you're going to get dinged. So keep that in mind. And that's pretty much the process for 6.4. So let's do a few more. Make sure we got it down. A bag of rice noodles that weighs 6 ounces makes 7 servings. At that rate, how many ounces of noodles do you need for 12 servings to the nearest ounce? Well, again, those two things are linked. So let's write that as one side of our proportion. So we had 6 over 7. And if you want to put the units in, that helps obviously get the other side. So now, okay, at that rate, how many ounces of noodles do you need for 12 servings? So we already know the servings is on the bottom, so the 12 is going to have to go on the bottom over here. And we don't know how many ounces goes on top. But we're going to find out. So let's cross multiply again. Let's do our x first. So we're going to have 7 times x, and then 6 times 12. And we know 6 times 12 better be 72, right? And then we can divide by 7. So, well, just so we don't make a mistake, let's divide that on the calculator. See what we get. So 72 divided by 7 equals 10.2857, and so on. Now, we got to be careful about rounding. So this question says to the nearest ounce. So they don't want any decimals in this one. So what should you round that one to? Yeah. So we're going to look at the 0. So the 2 tells us to leave that 0 alone. So we're going to round that to 10. So 10 ounces of rice noodles is what we're going to need for 12 servings. A little bit more if you want to put a dash in there, but okay, let's try the next one. This one's a little tricky because the units are kind of all the same thing. A stock market report says that 5 stocks went up for every 6 stocks that went down. If 750 stocks went down, how many went up? So we got stocks. So really using stocks as a way to kind of differentiate between them, it's not going to be very helpful. But we do know that some are going up and some are going down. So there's the distinction that we can use. So we have 5 stocks. So I'm just going to put 5 up and I'm going to put 6 down because that's what goes together, 5 and 6. So now we got to make sure we get the other side correct. So 750 stocks went down. How many went up? So we got to put the 750 on the bottom. Yeah. So 750 down. So we don't know how many went up. All right. So now, same thing as before. Cross, multiply, and divide. So let's do the 6 and the x first. 5 times 750. 5 times 750, I think, is 3750. And then let's get that 6 out of there. And again, just to make sure, as much as I know math, I like to make sure. Divided by 6 equals 625. All right. Now, how should we label this? We don't want to just say up, but remember it was stocks still. So 625 stocks went up. All right. So, like I said, hopefully you're starting to get a little bit of a groove, but anytime they have those pairs of things that are linked together, use that as one side of your proportion. So let's see if we got a few more, and that'll wrap up this section. We'll see if we can squeeze this in one video. All right. So at 3 p.m., Coretta's shadow is 1.05 meters long. Her height is 1.68 meters. At the same time, a tree shadow is 6.58 meters long. How tall is the tree? Round to the nearest hundredth. Well, we're going to have to draw some shadows and some trees and some people. So let's draw a tree. There's my nice little tree. And the sun is over here. So I'm going to have a shadow that kind of goes down like so. And I'm going to have Coretta. And I'm not going to be very fancy with Coretta. But there she is. And she's got a shadow on the ground too. So, okay. So now we got our tree, our shadows, and our girl. So her shadow was 1.05 meters, but she's 1.68 meters. And the shadow of the tree is 6.58 meters, and we don't know how tall the tree is. All right, well, how can we set up a proportion? So remember, you can use the things that are linked. So we know Coretta's shadow and we know her height. Those are linked. So if you want to put 1.05 meters over 1.68 meters, that would be good. And now where should I put the rest of the stuff? Where's the 6.58 going to have to go? Top or bottom? Well, remember the shadow is on top, so I need the shadow of the tree on top. So 6.58 meters, and I'll put an X on the bottom. All right. Now we're going to cross multiply again. So we want to do the one with the X first. So let's do 1.05X, 1.68 times 6.58. And I definitely don't know what that is. So let's do that out. So 1.68 times 6.58 equals 11.0544. Now, you might say, well, can't we just round that off to 11.05? You probably could, but it's going to give you a little bit of a round off error if you do that. So I would save any rounding until the very, very end. So don't round it while you're doing the problem. On the very last step, when you're about to write your final answer, that's when you can round. All right, so now let's divide by 1.05. Now I still have it in there, so that's nice. I don't have to retype it. So now let's just divide that by 1.05, and I get 10.528. Now we got to look at rounding. So what does it say for rounding? Round to the nearest hundredth. Hundredth, remember, is 2 decimal places. So we want to look at the 2, but the 8 says we need to round it up. So we're going to end up getting 10.53 meters. So there we go. All right, almost there. Let's do this last one, and we'll wrap this section up. On the floor plan, or use the floor plan to answer the question, on the plan, 1 inch represents 4 feet. What is the actual length and width of the kitchen? So we're looking at just the kitchen. We got 3.5 inches there, and we had 2.5 inches there. And we know that 1 inch is 4 feet. So how can we do this? Well, we're going to have to use 2 proportions if we want to do this technically. So the first one, though, is going to be using this conversion. We know that 1 inch is 4 feet, so we can use that as one side of our proportion. So we got 1 inch over 4 feet. And now the other side, let's start with the length. We know that the length is 3.5 inches, so where would we put that in our proportion? It's going to have to go on top, right? We want it to match up with inches over here. And we're trying to find the actual length in feet, but we don't know that, so that's our x. All right, so now we can cross multiply. So 1 times x equals 4 times 3.5. Well, 1 times x is nice because that's just x. 4 times that is going to be 14. So 14-foot length. And we can do the same type of thing for our width. The only difference is instead of putting in 3.5, we're putting in 2.5. So we still got 1 inch over 4 feet. And we got 2.5 inches over x feet, new x. All right, so 1 times x equals 4 times 2.5. So x equals 10 feet. So we got a 14-foot length and a 10-foot width. Now, if they want you to write dimensions, if they say write the dimensions of the kitchen or something like that, then you want to use, again, a proper notation. Usually they use something like this. They would say 14 feet by 10 feet. So they'll put, an X in there. Probably in the My Math Lab, they'll do that for you if they want you to write it as dimensions. So, all right. So that wraps up this section. So we'll jump into chapter 7 next, which is going to be all about percents. So fun, fun, fun. See you very soon.